Assalamu alaikum and good morning, my dear students. I am your teacher Muhammad Ikram from Pakistan International School, Taif, KSA. I welcome you all into my today class. Today it is lecture 12, unit 6. In my today lecture, I will explain you the potential energy. I will tell that what is potential energy, what are the types of the potential energy. Then I will move on to the gravitational potential energy, which is included in your syllabus, and then I will derive the relation for the gravitational potential energy. I will explain the factors on which the gravitational potential energy depend. Then I will tell the uses of the potential energy also. So let us start our lecture with the name of Allah Almighty. Bismillah ar-Rahman ar-Rahim. I give you a very light and short introduction of the potential energy to you in my last lecture. In my today lecture, I will explain it in detail, the potential energy. Potential energy. Potential energy, it is in fact the energy stored in a body due to its position or configuration. We call this energy as the potential energy. Like all other energies, potential energy is also measured in joule. In fact, there are numerous examples which I would like to share with you. For example, the first example here, you see the bow. When you stretch the bow in the direction indicated, then energy is stored in it. The rubber you see, the energy stored in it is called the potential energy. And when you release the potential energy, then stored in the rubber converted back into the kinetic energy, as a result which it caused the arrow to move in a forward direction. Another example is the aeroplane in the air. You see the aeroplane at a height h from the ground is has potential energy. Bird flying in the air, the football you see raised to a certain height has a potential energy. Another example is that energy in a spring, when you either compress or when you stretch, that has a potential energy in it. Another important example is, for example, you see a ball rolling down the inclined plane, then the ball has potential energy, right? At the height of the inclined plane, as it rolls down, then it will have a kinetic energy. So when you move it from here, right, to that height h, the ball gain potential energy. Now, even despite it, it's this difference that the energy stored in a body due to its position or configuration. That is not clear too much. I just want to finish this thing in a very smart sentence, and I would like to tell you that, let me just choose this, that potential energy is in fact, it is the energy which is stored. Bus. That is what the energy which the energy which is stored, the energy which is stored. Now, how it is stored? How? The question is what? The question is how? It depends. It depends on the situation, and I will explain the situation to you. But remember, whenever this energy, when this energy is what? When this potential energy, when released, when released, it perform work. It perform what? It perform work. And that is what we need. Now, the potential energy, as I told you, that it is stored, and then how it is stored, that is now I'm going to explain. Look, first I told that the position, you see, look, or the configuration. You see, when you stretch the bow, then that that is the energy stored in the bow is then what? Potential energy. So actually stretching causes this thing. Second, when you raise the object against gravity, for example, look at the aeroplane, look at the football, then because of this raising from the ground, then there is energy stored in it. And when the ball has the chance to release, then it will do work. Similarly, when you release the bow, then the stored energy, the potential energy, perform work. It changes into the kinetic energy and causes the arrow to move in a forward direction. And the same thing happens. We store the energy in a spring, and when and where we need, we can take it back. So this is how the potential energy is. But the story does not finish here. There are various types of the potential energy. The one we call the gravitational potential energy. Simple, I write it as GPE, but in your book, it is written as potential energy. And another one I like to call the elastic potential energy, EPE, right? The elastic potential energy. These are just the two I wrote to you. There are not just these two kind of potential energies. There are thermal potential energies. There is electric potential energy stored in an electric field. There uh, is the nuclear potential energy also, which is beyond the scope of our today lecture. But these two I will explain, and the only one which is included in syllabus is the gravitational potential energy, and there is very light introduction to the elastic potential energy. So let us come to the elastic potential energy first. Let's see what is the elastic potential energy. The elastic potential energy is the energy stored in a body due to its configuration, right? Are very simple word I would like to use, that is the deformation of the structure. Deformation of the structure. When you deform something, when you change, for example, the shape of something, look, you, it is very clear here in like this color is not this. You see, look here, this one and this one, as you see, it is being compressed. So this compression is deformation, right? And the energy is stored in a spring. Now when you release, then that energy will release too, and it will perform a work. And you know that there is no mechanical device which which does not use the spring. Even the retracting pen in your hand, maybe most of the students while noting down this today lecture, they have the retracting ballpoint in which spring is used. So you see, this is what this is the stretching. So in both the case, there is a deformation, and that deformation cause the energy to store in it. So that is known as the elastic potential energy. That is what, and that is called the elastic potential energy. So you see, look here in this case, there is which kind of energy stored in the bow. You just look, there is compression on this side and compression on this side, like this. So this causes the bow to bend, and this deformation allows the bow to store the potential energy. And when you release, then it will cause the arrow to move in a forward direction. So the potential energy will then change into what? Into the kinetic energy of the bow. Now, what is the potential energy? Potential energy is the energy stored in an object when it is raised against the gravity. Against the gravity. Or we can say that this kind of energy is the energy due to the elevated position of the object which has mass. Energy, what? The energy stored in a body due to its elevated, due to its elevated position, due to its elevated position, due to what? Due to the, yeah, due to better, due to the elevated position, due to the elevated position of the object or objects which has mass. Which has what? Which has mass. That is what we call the gravitational potential energy. This gravitational potential energy, the gravitational potential energy, it is given by the relation gravitational potential energy, which is simply written as potential energy, mgh. Now, what are these factors? That is, this is what the mass of the object in kilogram. That is the, this one, the gravitational acceleration gravitational acceleration, and this has value normally 9.8, or in your book 10 meter per second square. But as you know, this is not constant. As the objects gain height, particularly when it is at much greater or more height from the surface of the earth, then we are not supposed to use this value. This will get changed, and this is the height of the object in meter, and the potential energy is usually measured in what? In joule. So from this relationship, it is evident that potential energy increases with increase in the mass of an object. If you remember last time, in the while I was explaining to you the kinetic energy, at that point I told you that uh, if at that point I told you that if the mass increases, the kinetic energy increasing. Kinetic energy was directly proportional to the mass of an object. In similar situation, in this situation, much similar, the potential energy also, the potential energy is also directly proportional to what? To the mass of the object, while keeping its height constant. Similarly, this potential energy is also directly proportional to the height gained by the object. Height, this height is above the surface of the earth, right? Above the surface of the earth, surface of the earth. But this depends on the reference point above the surface of the earth. For example, a ball has a different potential energy with respect to the ground, but it has a different potential energy with respect to the table. So, and therefore, it always depends on the reference point, that which reference point you have chosen for calculating the potential energy for an object. So that is relation for, that is the expression for the potential energy. Inshallah, at the end of this lecture, I will demonstrate to you through some simulation that in which way the potential energy is useful to us, right? We use the potential energy uh, in various that is um, for the various job, right? Now, but first I want to derive to you this relation, that how we can derive this derivation. The derivation of the potential energy is very much simple, right? I just want to take this object, cut, and I want to paste it here for mm, sorry. Okay, you see, that is I now look the how to derive the relationship for what, for the potential energy. As you know that, look, as we know that that is the work done, it is the work done on an object, the work done on the object while raising it from the point, from this, let's see, from the point here, you want to raise it from the point A to a certain height to the point B through some distance like S, right? So because you already know that work done is equal to what? It is equal to F, the force, into what? Let me use one gram of pen, sorry for this. This, let this work done is equal to what? It is equal to F into S. So our work done while raising the ball from the point A to the point B is equal F into S. Now, what is the force here? And what is the distance here? You see, usually we denote the vertical distances by h. All vertical distances are denoted by h. So our s equals h, the vertical distance. So that is a very easy task. Now, how much force, right? That is the force F while lifting the ball from the point A to a certain height h. This force F on the ball is in fact equal to what? This force F. It is equal to at least the weight of what? The weight of the ball that is lifted in this case. So what does this means? That the work done, that is the force while lifting the ball from the ground to the height, is equal to the weight of the ball, right? W, which is equal to mg. Now, class, I want to tell you one thing. Let us see here. The capital W indicates work done, which is purely scalar quantity, while the small w, it is weight, right, which is a vector quantity. So there is a chalk and cheese difference between the two. You must understand this difference, right? So the force you have got now. So now let us go back to our equation, and this work done is equal to what? M into G into H. So this is so easy, right? As easy as eating ice cream. Just two relation and you get the required equation. Now this is what that is the work done, but we know that this work done, what this work done on the body is stored in what? Is stored in the form of what? In the form of kinetic energy, in the form of in the form of potential energy of the body, potential energy of the body. Okay, how? Why? Because you know that work done always what? That you already know that. Many time I told you that work done does what? That work done on the body increases what? Increases the kinetic energy of the body. The kinetic energy of what? The kinetic energy of the body. So when you do work done, it increases its kinetic energy. Now look, that as the ball is, if you raise the ball from the ground, what happens? It's kinetic, that is that the work which you do on the ball, it changes into what? Into the kinetic energy. As the ball rises, what is the formula for the kinetic energy? The kinetic energy, you see that kinetic energy, look, the kinetic energy is equal to what? The kinetic energy half mv square. So you see, as the ball rises, so since this motion is against the gravity, then the speed decreases. Speed decreases. So the kinetic energy decreases, but what happens? Its potential energy increases, and at this highest point, the ball has the potential energy equal mgh. So the entire kinetic energy appears in the form of what? It appears in the form of the potential energy of the ball. So that is what I'll write, that potential energy is equal to mgh, right? Now look, the greater the mass, the greater the height, the greater will be the potential energy. Now, as you know, for example, look, in space, what will be your potential energy with respect to the Earth surface? Definitely, you will have what? You will have the potential energy that is in the space. The value of G is very small. That is nearly equal to zero. So what will be your potential energy there? your potential energy will be zero, and this is why you are not falling towards the earth, you are just floating there, right? Your potential energy with respect to the earth surface is zero, right? Now look, if you want to store more energy, then you increase what? You increase the height of the object. This is why you see when you construct a dam, you just give a very large height to it. Why? Because so that the water has the greater height, the greater height, then it will have, when it fall, then it will have the greater potential energy, or you can say the depth. So this is the relation for the potential energy. So the potential energy is actually, you can say that it is our kind of energy bank. I would like to tell potential energy is our what? The potential energy is like our energy bank. It is our what? Energy bank, where we store what? Where we store energy. In the bank, you store money, and in this we store here what? The potential energy. So that is the various, it is stored in a various way. It can be stored in the form of stretching or compression, as example of spring or bow. It can be stored in the form of what? Mm, Water in a dam. The potential energy can be stored in the mm, form of what? It can be stored in the form of electric field also, when we talk about the electric potential energy. Sorry. So this is how we can explain the potential energy. Now let me show you some simulations about the potential energy. So let me show you. You see, now look, the when he stretches the bow, which kind of energy is stored in the bow? Of course, the potential energy. You see there is a deformation. That deformation causes the bow to bend, right? That bending has the energy, they are stored in the bow, and when you release the bow, the potential energy changes into kinetic energy, and the arrow moves in this direction. So this is how the energy, this is how the potential energy is stored in an object. And the next you see here, look, the ball. In this case, you just see, look at the ball. And it's not cause any simulation. You see, look, as the ball gain height from the ground, then what is happening? You see, look, its potential energy increases as it gain height, right? And as it lose height, its potential energy decreases, and its potential energy decreases, becomes zero, kinetic energy increases, and now like this. So this is another way of storing energy. Now another example is like this. See here in this simulation, you just see, look, the water is stored in a dam, and you see the dam is at height. The dam is at what? The dam is at the height, at a certain height h, as you see. Look, right? So what is the potential energy of the water? Of course, it will be mgh. Now you know, when the water moves, then the moving water has a kinetic energy. So the potential energy of the water, which is stored in a dam, now changes into the kinetic energy. As the water passes through a tunnel, then there is what? A turbine. It runs the turbine runs a generator, and this is how electricity is produced, and which is then supplied to various cities, town, etc. Like, so this is how we can use the this is how we can use the potential. So in the today lecture, you have learned about the potential energy, the type of potential energy, which are gravitational potential energy and elastic potential energy. You have seen how the potential energy is stored, what causes the energy to store there, and then you have seen how we can get that energy back and then use. Then you have learned how to derive the equation for the potential energy, and inshallah there will be some question which are based on this equation, and then we will solve them. So thank you very much for being with me.